Welcome to Falcon TV. Subscribe to the channel to stay informed and inspire us.
Building your own electric car from scratch is an incredibly rewarding and challenging project. It allows you to learn about automotive design and EV technology hands-on while creating a fully custom vehicle. With proper planning and effort, an EV can be successfully built by a knowledgeable hobbyist in their home garage. While it requires fabrication skills, electrical know-how and attention to detail, the project is attainable if undertaken systematically. This comprehensive 100-step video covers the full process from initial planning to final street legalization. Let's get started. Planning and design. Research design considerations, legal regulations, vehicle dynamics, aerodynamics, chassis types, materials, safety, etc. Define target specifications, weight, dimensions, power, torque, speed, acceleration, range, seating capacity, features, etc. Calculate approximate battery capacity and motor power needed to meet specs. Make initial concept sketches, top, side, front and interior views. Create 2D technical drawings of chassis, drivetrain, steering, suspension, electrical systems, etc. Use CAD software to model exterior and interior in 3D. Refine shapes and details. Engineer detailed plans for each system, frame dimensions, motor mounts, battery boxes, wiring diagrams, etc. Specify all materials required, tubing gauge, motor kW, cell chemistry, circuit breaker amps, etc. Chassis, body. Design chassis frame in CAD, select tubing sizes, mount locations, triangulated geometry. Acquire steel, aluminum tubing in sheets for the build. Check specs and quality. Cut tubes to required lengths using chop saw. Miter ends at precise angles. Notch tubes and drill mounting holes as per frame plans. Deburr edges smooth. Tack weld chassis segments together in a jig to ensure alignment. Finish weld all seams using MIG or TIG process per specified settings. Smooth welds using an angle grinder. Wire brush entire frame to remove slag. Clean frame thoroughly to remove all grease, rust and debris. Fabricate custom mounts from steel plates for motor, batteries, suspension, etc. Bolt or weld mounts to frame according to design blueprints. Create male plugs using modeling clay to use as female fiberglass molds. Apply wax layers to plugs. Buff and polish surfaces smooth. Spray gel coat in molds and let cure before laying up fiberglass. Apply epoxy resin and fiberglass mat in layers to desired thickness. Trim and bond body panels together using more resin and fiberglass. Attach hood, doors, trunk lids using piano hinges, latches and gaskets. Mount completed body to chassis frame securely. Motor, drivetrain. Obtain electric motor AC or DC type with enough power for specs. Test motor operation on bench before installing spin test, resistance check. Select appropriate motor controller capable of delivering required power. Machine adapter plates to bolt motor to frame mounts. Install drive axle, wheels and align motor shaft angle precisely. Attach drive couplings or sprockets to transfer power to wheels. Add torque arm to restrain motor from twisting under power. Use rubber isolators to reduce vibration transfer from drivetrain. Install cooling system, radiator, pump, hoses, coolant type and mix ratio. Add temperature sensors on motor and controller with warning indicators. Batteries, charging. Calculate total battery capacity needed using weight, power and range goals. Select suitable lithium battery cell chemistry, NCA, NCM, LFP, etc. Obtain cells and confirm specs match requirements, voltage, capacity, max draw. Connect cells in series and parallel combinations to achieve pack voltage and capacity targets. Design battery pack enclosure with segments, spacers and forced air cooling ducts. Assemble pack using bus bars, bolts, welds per design. Protect cells from impacts and vibrations. Include BMS for monitoring cell voltage, temperature and balancing. Add main fuse or circuit breaker rated for maximum draw. Install charging plug, socket and AC/DC converter designed for battery pack. Choose charger profile compatible with battery chemistry. Electrical systems. Select DC-DC converter to step down high voltage from battery pack. Choose appropriate wiring gauges and insulation ratings for currents. Install control panel with gauges, indicator lights, buttons, switches, etc. Wire up lights, auxiliary systems, safety cutoffs, charging system as per diagrams. Route cables in conduits and wire looms. Provide slack for motion. Use properly rated terminals, lugs, cable glands and connectors. Add data loggers to monitor voltage, current, temperatures and faults. Connect all systems to common ground point on chassis. Protect all circuits with properly rated fuses or circuit breakers. Check wiring thoroughly before powering on electrical systems. Suspension, steering. Design front and rear suspension systems, double wishbone, McPherson, etc. Acquire compatible donor components where possible. Fabricate suspension mounting brackets and attach to frame per blueprint. Assemble and install front and rear suspension systems. Attach steering rack, tie rods, steering shaft and steering wheel. Install adjustable coilover shocks and springs. Add anti-roll bars and camber adjustment where required. Measure and adjust suspension geometry, caster, camber, toe, bump steer. Braking system. Install brake pedal with matching master cylinder bore size. Add brake booster if needed based on system brake pressure. Mount brake fluid reservoir and fill with recommended fluid. Install distribution blocks and steel brake lines with proper flaring. Connect brake hoses to calipers with bleed valves. Ensure clean interior. Add front and rear disc rotors and calipers based on brake bias. Include parking brake functionality on rear wheels. Connect region braking control from motor controller. Pressure test completed system. Bleed brakes to remove all air. Confirm proper brake pedal feel and test stopping distance. Interior, exterior. Install adjustable seats, secondary controls, steering system, sound system. Add interior door panels, carpet and insulation for noise reduction. Mount center console with switches, buttons, displays and controls. Add side mirrors, wipers, lights, turn signals and other accessories. Apply paint and polish body panels. Add custom graphics as desired. Tint windows and attach trims, bumpers, grills and fender flares. Upholster seats and panels. Add safety padding where required. Testing, validation. Put car on jack stands and test all electrical systems thoroughly. Confirm measurements and fittings of parts installed, match plans. Pressure test coolant system. Charge and vacuum test AC system if added. Spin test drivetrain at low speeds to check for vibrations and noise. Test drive in empty parking lots starting at low speeds and with safety gear. Validate controls, instrument reading and system functions in test drives. Perform aeration, braking, handling, noise and all functional tests. Inspect all parts for abnormal wear or heating after testing. Make all adjustments and fixes needed before driving on public roads. Finishing and legalities. Add final interior accessory screens, upholstery, cosmetic panels, etc. Clean, polish, wax and detail exterior body work for desired finish. Install VIN identification plates to meet legal registration requirements. Research and complete process to register a homemade kit EV in your state. Acquire car insurance specifically for an electric low-volume vehicle. Drive short distances on local roads to validate controls and range. Have car inspected by certified mechanic familiar with EVs. Make any final adjustments noted in inspection before daily driving. Install home charging point with appropriate power supply and rating. Consider additional safety mods, roll cage, fire suppression system, etc. Share your build details and help others attempting EV conversions. With meticulous planning, patience and persistence, you can design and build a fully functional electric car in your own home workshop. This DIY project will lead to immense satisfaction as well as a deeper understanding of EVs. While lengthy, these 100 steps try to cover all aspects needed to convert a custom EV design into reality.
If you liked this video, please subscribe to the channel and give a thumbs up. Thank you.